Hello everybody, welcome to this video on examples of calculating partial derivatives. So as you can see, there's three functions, and in this video I'm going to talk about the process for calculating the first order partial derivatives. Okay, so let's start with A. We have some polynomial in x's and y's. B, we have exponential function being multiplied by some polynomial in x and y's, and C, some trig function, again some polynomial in x and y's inside of the trig function. So let's start with A. Let's go to a clean sheet. Our function takes some xy and produces the number 2 times x to the power 3 plus x times y plus 4 times y to the power 5. So let's begin with the partial derivative with respect to x. So what do we need to keep in mind? Well, x is varying and y is fixed. Y is some constant. Okay, so all the usual rules for differentiation in 2D apply, and wherever we see a y, we just think about it as a constant. So the first term, no y's, just x's. Differentiate with respect to x. The 3 comes down. 2 times 3, x squared. That's the first term. The second term, x times y. So we know y is fixed, so this differentiates to the constant, the number in front of x. And the final term, there are no x's, so if there's no x's, just y's, it's just a constant. And if you differentiate that with respect to x, then you get 0. So the partial derivative of f with respect to x is 6x squared plus y. Okay, so that's the first partial derivative. The second one studies how the function changes with respect to y. So this time x is a constant. So if we go to our first term, x is a constant, so 2x cubed is also a constant. So if we differentiate with respect to y, we get 0. The second term, x times y, x is a constant sitting in front of y. This just differentiates to x. And the final term, 4y to the power 5, differentiate with respect to y. It's just the usual rule for differentiation. Bring the power down. So 4 times 5 is 20, reduce the power by 1. So the partial derivative of f with respect to y is x plus 20y to the 4. Okay, so there's your first example. Just a little bit of playing around with it till it feels comfortable. Let's try the next one. So the next one, g. Okay, let's write it in a new sheet. G takes some point x, y. It calculates y to the 4 plus x and multiplies that by e to the power minus 3xy. Play the same game as before. We want to differentiate this with respect to x. Okay, so what patterns do we keep our eye out for? Well, x is varying. I can see an x in this factor, and I can see an x in this factor. So if I differentiate, I'm going to need the product rule. Okay, so the product rule, you can think about f and g, and then use the product rule. Actually, it's a clash of notation. I better not do that. And we can just jump straight in with the product rule. Okay, so differentiate the first factor with respect to x. So y to the 4 goes to 0. X differentiates to 1. That's just 1. Keep the second factor the same. Okay, now the second term, we keep the first factor the same and differentiate the second one with respect to x. So differentiate e to the power minus 3xy with respect to x. The standard derivative, the power differentiates to minus 3y, and we just bring that down. Okay, if we want full marks for the question, looks like we need to do a bit of simplifying. What can we see in both terms? Whoops. So we have e to the power minus 3xy in both. So let's factorize that. So there's a 1 in the first term and that in the second. Again, I think I can do just a little bit better than that. Just going to expand the bracket. Minus 3y to the power 5 minus 3. I'm going to write the x first, go alphabetical order, and just double check that. That makes sense. Yep, that makes sense. Just being careful with the algebra. If we differentiate g partially with respect to x, we get this. Okay, so that is how g changes with respect to x. How about with respect to y? Okay, so now we need to change our mindset a little. X's are now constants and y's are now varying. So if we take a look at the function, there's y's here in this factor and y's here in this factor. So we're going to have to use the product rule again. Okay, so differentiate the first factor with respect to y. Keep the second factor the same. Oh, we don't need that bracket. Now keep the first factor the same and differentiate the second factor with respect to y. Okay, so differentiate the power minus 3x. Keep the power the same. Okay, so there's the derivative. Again, in an exam, we might lose a mark or two if we don't simplify as much as possible. So I want all the marks. I'm going to keep going. I'm going to simplify. So I'm going to factorize. I can see there's an e in both terms. So factorize that. I'm going to write that negative 3x at the front. I think it'll make life easier on the final step. Okay, that makes sense. Yep. And finally, let's calculate what that square bracket simplifies to. So we have 4y cubed. Oh, nothing terribly exciting. Let's expand the bracket. I can't see any cancellation. So there you go. The partial derivative. Whoops, I just realized there should be a y there. The partial derivative of g with respect to y is this box. Okay, and that helps us study how the function changes when you move in the same direction as the y-axis. Okay, one more left. Part C. This time we have a trig function. Let's take a look at differentiating that partially. So h takes some point xy, xy plane, produces this number. This number effectively is the height when you plot everything. It's on the z-axis. Okay, and we want to study how this changes with respect to x. Okay, so standard derivative. I'm not sure if I need to write it. I'll write it whilst I'm here. standard derivative is the chain rule. Sine of some function differentiates to cos of the function, all multiplied by the derivative of what's inside of that sine function. We should all know that. So applying that here with respect to x, sine differentiates to cos. Whatever's in the bracket stays in the bracket. And finally, we differentiate what we see inside of the trig function with respect to x. That goes to 6x squared. Okay, the second term differentiates to 0. It's a constant. There's no x in there. That one wasn't too bad. Okay, how about studying how it changes with respect to y? Well, same principle. Sine differentiates to cos. Whatever's in the bracket stays in the bracket. And then we differentiate the bracket, this time with respect to y. So we have 0 in the first term. It's just a constant. Minus 15 y to the 4 in the second term. So I think I'm just going to tidy it up just a very little bit. I'm going to bring that minus 15y to the 4 to the front. And then cos of that business gives us the final answer, which takes this form. So there you go, free functions and their first order partial derivatives.